Mark here. We're back at Metal Pete shop, and we are testing a
Metal Pete here, and I'm showing him my Stratofan that I got from Mark Welker, because to show him one thing, I want to show him it's not a gold line. Remember you asking me about my brown gold line? I said no, this is a Stratofan.
Given the uncanny resemblance.
They are quite alike. Now usually when I fan test, I'll actually turn them down, you know, because I want to do an airflow test, so I'll usually turn them down. I'll keep them on though, but I'll turn them down. I'll turn this one down. Okay, so this is how the test rig works, if you remember.
Oh yeah.
What we do, now on an industrial, since you know there's no pull chain, we right away do, I'm going to set the amp meter to amps, so there's no amps. I would put the camera here to aim it at the fan when doing a fan video, and have the meter in the shot.
Oh, nice.
And Dan showed me that, because he has that meter now too.
Yeah.
As he saw in his videos, but I'm going to show him the Stratofan. Now what we do is, since there's no pull chain, we're going to do what's called the 0 to high first, which is, if I want to go through the test rig, this is the straight on-off switch, which is high, I call high. So if it's a non-pull chain fan, it's just going to go right to high. And then this is the decade box to simulate like the 4-speed controls. And then of course we have a solid state variable to show how it would run on that. And then these are also capacitance to add to the decade box. Like I have one that adds 10, the other to add 20. So 10 plus 1, that would be 11. Or 20 plus 1, 21. And you can get a total of 40 microfarads. So what we're going to do is going to do a 0 to high first. So since you're here, you can hit the 0 to high, and which is the black switch there on. 0.76 is what it jumped up to on the meter there. I usually watch for what's called an inrush.
Love that sound.
I do too. Oh yeah, the old gold line sound.
Yep.
I mean, it's not quite as fast as like a gold line per se, but
Sounds just like my 79s.
yeah. Oh yeah. Now it is drawing 0.75 amps is what it's drawing. Now what we also do, now check this out. I can test the watts, and that's doing 81 watts. And then I have what's called a power factor, and since the power factor shows more of a percentage of what it's using, it's showing 0.95, so that's practically what I call a power factor of 1. That means it's almost practically using 100% of current that it's drawing. Now, a lot of times, like fans, like if you do low speed on a pull chain fan,
Yeah.
it's like only using a quarter power factor. Quarter power factor of the amount of current that it says it's drawing.
I gotcha.
And then, so this one's got a power factor of 1 on full speed. And usually what we do then is turn it off for a spin down. You know. Now it's drawing no current. So this one kind of has a long spin down.
Oh yeah, good bearings.
Yeah. But that one came from the bowling alley. That Mark pulled it.
Yeah, I see a lot of brown gold line-ish things in bowling alleys.
Oh, yeah.
A lot of them are labeled Brunswick.
Yeah. Yeah. Oh, Reese got an HRS one that was like union made.
Oh yeah.
Technically has that thick motor, rounded bottom.
Yes.
But it has a gold banding in that whole middle. Kind
Oh really?
Like that jab.
Huh.
Because that jab in the museum is union.
Yeah.
But that's got that same motor. But that one was labeled HRS. Okay, now, next thing what we do, since I want to show you the decade box, is we do what's called the decade box, and we go up one at a time to see where it starts at. Like 1 microfarad, 2 microfarad.
Cool.
Alright, if you're ready.
Alrighty.
Go for it. 1, 2, 3, 4, 5. Might take more. Oh, it's just starting on 5. And you probably want to go to 6. See what's it drawing? 0.23. Okay. Let's go to 7. Now, one thing I remember what I used on this was I actually used 8. So I was going to go to 8.
Alrighty.
Here's show you why, because one of the things with going to 8, this is the low speed that I would get on an 81220.
Okay.
This is what I'd get for low.
Yeah.
So I've learned, yeah, both this, the Union gold lines, the old gold lines, work best on an 81220 for speeds.
It's a good low, you know.
That's a perfect low. You know, it's not too slow to not do anything, and it's not like too fast to be a low.
Yeah. There's actually a library in my town that had a whole bunch of white gold lines that were always running. It was a solid state control. You could hear them buzzing.
Oh, yeah.
And they were always running on low, just like that. All of the ones, you know, there were 2 in the lobby way up there when you first come in, and side rooms had 1 each. The was in hallway that had 2 of them. There were 4 in the main part of the library, and you could always just hear them buzzing and spinning on low. So.
Oh yeah, but as you notice, if I want to turn off the Dayton,
It's pretty much silent.
yeah, on a low, it's silent with capacitor-based control.
Yeah.
Now, usually I go up 1 microfarad at a time, but what I'm going to do is go to 10, go back to 2, go back to 2 and hit the 10, and see what it does there. Now it's drawing 0.39 amps. Now see, that's more like, that would be like from 8 to 12. That's your medium low.
Yeah, the 12, right? Yeah.
That's a medium low, and that's like your perfect medium low, and you want it to go a little faster than low.
Right, right.
You know, you can, that's like your perfect medium low right there. Or, now there's 2 ways you can do this. Next speed here, I just go all the way up to 10 here. So from medium low, I'm just going to jump all the way up to 20. Notice how that's like a high medium or a backed off high.
Yeah, yeah.
You know, there's that. And then I'd hit high. So then you got your 4 speeds. Just like so. You know, going from 20 to high, you can notice the difference. You got full power, and then you got the backed off high.
Oh, yeah.
You know, it's like you get the perfect speeds out of that. Now, the standard wall control on this one, this is the same as my living room one. On the modern gold line, I get the exact speed range I'm looking for. Or even the high medium is exactly what I want it to be.
Yeah.
Low is what I want it to be. Even low medium,
Yeah.
it's exactly how I want it to be. And then the other test I usually stop them by hand after this. Just because I don't need to see it spin down every time. Alright, then I do what's called the solid state. What I have to do is switch it from cap, which is all of this, capacitor system, to solid state, and now the power goes through this.
Okay.
So you can just start inching it up until it starts and see how it reacts. And compare. Oftentimes I test it especially at low medium.
Yeah. Definitely hear that buzzing.
You can, but it's not actually bad.
Oh yeah, come on, mild buzzing, yeah.
It's really quiet. It's not loud buzzing.
Yeah.
And there are some that do it worse than that.
Oh, absolutely, yeah, I've heard them.
That's actually not bad. I can take that for the living room. If I had to put something on a solid state like this, I could take that for the living room. It doesn't need to be the bedroom.
Yeah.
For sleeping in, the living room is fine.
Oh, I need noise to sleep.
Well, actually, wind noise will do that for me.
Yeah, exactly.
And that's why I love my Ascension.
Yup.
I mean, the wind noise from the Ascension will do nicely. And then usually what I do is compare. This one's pretty close with the solid state high versus straight high.
Yeah.
What I do is I can compare. Like I hit the high so I can flip it. There's really no difference.
Yeah.
This one's really good with solid state. But some solid state, it actually is slightly less on solid state than straight high with current draw.
Yeah.
Are just a little bit. It's not quite a straight clean AC with solid state. There's that little bit of DC in it.
Okay, yeah.
Kind of like a dimmer switch, but the fan control type filters a lot of it out. So that's one thing about that. Since we already did 0 to high, I'm going to probably test another fan here.
Nice.
So I'll be right back.